Thanks so much to the Society for the invitation to speak today. And as a not neurologist and not really related to MS, I hope what I say will actually be of help, but I think there's a lot of overlaps between a variety of autoimmune diseases where it can be helpful to learn. My goals today are identify key items in developing prevention models that you all can work on in your area. And I'm going to particularly give you lessons learned from rheumatoid arthritis and throw in a few other diseases as well. Certainly rheumatoid arthritis, or RA, is not MS, but there's, I think, similar models. My experience is I've done several natural history studies of rheumatoid arthritis. I'm the principal investigator of the STOP RA trial, which is an NIH-funded prevention study in rheumatoid arthritis. And I'm also a participant in development of guidelines and classification criteria around rheumatoid arthritis, and importantly, this concept of pre-disease. Here's a huge list, and I hope I can cram everything in 15 minutes. The top three I'm going to touch on and then really delve into the bottom six throughout the talk. You all have to have enthusiasm and interest, and I think that's already here. I mean, basically, your field has got to be sick of waiting for people to get sick with the disease, to really try and move it into an earlier phase when you can actually drive prevention. Unless people are really hot on that topic, you won't move it ahead, but it sounds like that interest is already there. You need to engage a host of participants, which I already see that you're doing. That these are people who are at risk for these diseases, people who have these diseases, a range of biomedical investigators from your basic scientists to your clinical investigators. You have to have foundations, industry, and government all involved. And you have to have funding to do all of that. That's not only funding for research, it's ultimately planning business models for how you're going to drive forward prevention once you get there. The last six things I'll just touch here, and then I'll work through each of those points very quickly in the next few minutes. You want to have a reasonable model of natural history and biology of disease, which requires huge investment into natural history studies and longitudinal cohort studies, such as the 10,000 kids study that was proposed here. You have to find biomarkers that can identify stages of disease. You have to have predictive models for the next worst stage of disease. You got to implement prevention trials, and you got to agree on nomenclature, and finally get networks. And I think a lot of these are going to touch on things I've heard earlier today, and I apologize I was not here yesterday, but hopefully these will weave into things you're already thinking about. So I'm going to start, though, with this. What's the right term in prevention? Primary, secondary, tertiary. And I'm saying this because I have been beat up for a decade on what term I'm using and what the hell I'm talking about. And it's actually very difficult to apply these terms as you grow your understanding of what a disease is and when it may start. And so you can fight me on this later, and maybe by email. Perhaps a better operational definition is clearly identify where someone is at now, what stage that is, and then understand their risk for progressing to what you might call the next worst stage. And maybe step back from the primary, secondary, tertiary prevention, because I think that may limit us, because I think I'm supposed to be talking about secondary prevention, but I will say that secondary prevention is such a big bag of things that really thinking about it in this way makes more sense. And then what you really want to do is prevent or delay or modulate that next worst stage in a stage-specific manner. So think of these as I'm talking. I'm going to start with this reasonable model of natural history and biology of the disease. Okay. I'm going to show you what we know about rheumatoid arthritis, and I think you can plug in MS into this picture. And this slide takes a bit of time, but I'll whip through it. So we think rheumatoid arthritis starts with a genetic risk and then environmental risk factors. These are not all known genetic risks, but they're there. We don't know all the environmental factors. Then there develops a period, which is lucky for us, if you want to think of it that way, for our disease, where there's local and systemic autoimmunity in absence of end organ pathology, as far as we can tell, that can be measured by things I won't tell you more about, but blood-based biomarkers, things we call ACPA, rheumatoid factor RF. Then that can develop to a subclinical phase of disease that may only be detectable by imaging studies or other modes of evaluating. So this might be akin to MS that has a limited presentation. You might see something on MRI, but the person feels well. Then that can move on to an unclassified period where you'd say, yeah, they look like they're sick with arthritis, but I don't quite know if this is rheumatoid arthritis or many other kinds. And then that can finally move to classifiable disease, which is where we have classically studied rheumatoid arthritis, because this is when somebody's showing up to clinic with lots of swollen joints, say, haha, disease is present, we got you. So there's some pictures here. I won't go into that. We've actually now been able to divide rheumatoid arthritis into these interesting two parts. There is a non-articular phase or non-arthritis phase of this disease, and then an arthritis phase. I think MS probably has this as well. It may not actually start in the brain. The initial immune abnormalities may be outside of that. Understanding that's going to be critical because this will matter, because if you catch somebody in a non-articular or non-arthritis phase of rheumatoid arthritis, it may require very different interventions than when they actually have arthritis. So think about that. And this red block is where we've classically diagnosed people with rheumatoid arthritis. There's also some symptoms that come along with this. I won't go into that. There's probably ongoing genetic and environmental risk factors that are going to be important for you all to understand, because a trigger for initial MS-related autoimmunity may not be the same thing that takes somebody from initial autoimmunity to full-blown disease later on. And understanding that there may be differences is important. EBV, for example, I'm shooting from the hip here, but what if EBV is really something that transitions somebody who already has risk for MS into full-blown MS, and it's not really the inciting factor? You're going to want to know that. We have determined that there's a term that we can use called pre-RA, and I'll talk a little bit about this, that this now is this new thing that we're talking about, where now we're trying to label people with this if we can and clearly define it. That's going to really help y'all. Okay. What did it take to develop this model? This is where you're going to feel good and feel bad. It took years of research and decades. In fact, one of the first big studies was a 20-year study that was published in 1988. So 20 years before that, they started the study in a very high-risk population for rheumatoid arthritis. It's taken us since 1988 to now to see where we've gotten. Don't be dismayed. Learn from that and accelerate things. Do your studies that you need to do. But think about this. It's going to take a lot of investment into that. You're also going to want to make sure you're getting ongoing feedback from your studies as things progress. So I'm going to move very quickly through these 6 items, and I, again, apologize. I think you should all have these slides, though, so you can look back. You want to find biomarkers that can identify stages of disease. And when I say biomarkers, it's broad. RA, we're lucky, again, if I can use that term. We have a blood-based biomarker that's pretty predictive of somebody going on to get rheumatoid arthritis in the future. Find your own biomarker for your disease, whether that's imaging, whether that's combinations of immunophenotyping, which we talked about. You got to do that. Work on that. These, importantly, biomarkers have got to do several things for you. They've got to clearly define where a person is in the whole spectrum of disease, and they have to inform the biology of that disease if you can do it. Because if your biomarker not only identifies somebody at risk for moving on to the next worst stage, plus it tells you what you might want to intervene on to improve it, that's going to be a win. And you certainly want to make sure that these biomarkers can actually predict a future worst state. Nothing like a biomarker that doesn't really tell you about your next worst stage of disease, so make sure you can do these things. These can really include a broad list, which I won't go into. They can actually be things a person can tell you, like my mom had MS, and that's a biomarker in my opinion. It can do genetic tests, blood tests. It can be non-blood-based tests. And emerging in rheumatoid arthritis is a sputum test. You cough into a cup, can predict your future risk for rheumatoid arthritis. What if we could figure that out for other diseases as well? You know, you have challenges if CSF is your fluid of choice to identify a biomarker. It's daunting, but what if you could find a better way to get CSF than we've ever thought about before, because it's super important and there's easier ways to get these things. Think about all these things. Find your biomarkers. That's where I'll leave this one. Predictive models for the next worst stage. I'm just going to give you an example from rheumatoid arthritis, and you can apply this to your own disease. So the Dutch developed predictive model that includes 9 items, that includes a blood-based biomarkers as well as questions you can ask somebody that can actually quite highly accurately predict somebody getting rheumatoid arthritis. This is a very busy slide. Just look at the red line on the bottom. If you ask somebody and do simple blood tests, you can give them a score, and you can predict reasonably their risk for getting rheumatoid arthritis within the next few years. In a score of 7 to 12, largely based on a blood-based biomarker, you can estimate 50% chance of getting rheumatoid arthritis within the next 2 years. And understanding that model has really underpinned prevention studies in rheumatoid arthritis. So again, I'm moving very fast. I'm sorry if this will leave you disappointed in some ways, but hopefully this will be some key points. Once you gotta next do is take all those things and try and implement prevention trials. And I'm gonna probably spend a few minutes on this because I think this is important. But also understand that what rheumatoid arthritis has done, it's important to understand what we talk about when we say prevention has been attempted. And this is back to my operational definition of what we're doing. We're actually trying to stop or delay a next worst phase of disease, which for rheumatoid arthritis the field has agreed upon, is stopping the first swollen joint on examination. Put that onto MS world. What might that be in MS? Think about that. And then, importantly, most studies we call prevention in rheumatoid arthritis have been implemented in individuals that already start to have joint pain. And you go, well, that's not prevention. They've already developed some symptoms. Well, it's where we had to start. And you may want to think about prevention moving slowly back from a full-blown disease state to a very, very early phase to get data to be able to even go back earlier than that. And several studies in rheumatoid arthritis have actually even included a joint inflammation based on imaging that we can't otherwise see if on physical exam. We couldn't say your joint was swollen, but imaging showed it. That may be very akin to what needs to be done in MS as you move back in time to treating this disease earlier and earlier, using perhaps just an imaging finding. So this is hugely busy, and I'm not going to read through all this. I will say we guessed and did several clinical trials in rheumatoid arthritis to prevent. First, we gave steroids a decade ago now, over that. Then we gave a single dose of rituximab in another study. Then we gave a statin, which there was some biology behind that. All of these were designed around, we had biomarkers for prediction, and we had a general idea of how to implement these studies. None of these studies worked to prevent rheumatoid arthritis. So I don't want you to walk away thinking they know how to prevent rheumatoid arthritis. We don't, but we're a wee bit ahead of some other diseases because at least we're trying, we're implementing clinical trials. The one win here is that we actually, rituximab delayed the onset of rheumatoid arthritis. And so that's driving forward some other studies. I will also just have your eyeballs look at the right-hand side of the screen. I have a few numbers highlighted there, 21%, 37%, 24%. We guessed in each of these studies that 50 to 70% of people were going to get rheumatoid arthritis. Our prediction wasn't great. The top one, we thought 50%, only 21% went on to get the actual event. So you have to remember your prediction models are going to be helpful because these studies were probably underpowered based on our estimates. So you have to keep doing an iterative process to determining how well your models are working. A couple other trials I'll talk about here. One is this, we also have to come up with clever names. That's a whole nother talk. Treat Earlier is a study that was just completed in rheumatoid arthritis. They actually missed on the prediction. If you can see the highlighted numbers, 19 and 18%. They thought more people were going to get rheumatoid arthritis in this picture, but a subset, which was really high risk, 61% developed rheumatoid arthritis, which was quite good. They treated with a drug called methotrexate. Some of you may be familiar with that. I won't go into details. It did not prevent rheumatoid arthritis, and this is a very busy slide, but think of the red arm in these slides. These are the people who got the drug. They went on to get rheumatoid arthritis, but they had a more benign version of rheumatoid arthritis that persisted for a year. And this has shaken the field because what if you could say, well, you might get MS still, but the intervention I gave you, you're going to have a very, very puny version of MS that's not going to disable you. Wouldn't that be amazing? So you have to start thinking about your outcomes. It might be great to prevent a disease from ever starting, but if you could actually modulate it with an intervention that's early on and prevent that disease from being very severe or a next worst stage, that would be a win. So just a couple points on drug choice and duration. It's understandable what we've done in rheumatoid arthritis. You probably didn't catch this, but all those drugs that we've used in RA prevention studies are drugs we know work in established disease, and we moved them back earlier. We had to do that because regulatory agencies said you can't use some brand new thing in this whole new field. You have to take something that has established safety and improvability in that drug. So that's where we started. The problem is that those drugs may not be right for that early stage of disease, and we have to rethink that process. Because you probably wouldn't treat EBV in a full-blown, well, if I'm wrong on this, I'm sorry, but you might not treat EBV in a full-blown MS, but it might be the key thing in the early disease. You have to start thinking of those differences. The other thing is we gave very limited time dosing of these drugs in all of these prevention studies. That was partly regulatory, partly our focus groups, people who said, I don't have rheumatoid arthritis, I don't want to take a drug forever, so let me just have a limited point. So we shot the moon with these studies, and we said we're going to give it to you intervention for a limited time, see what we're going to do long term. We had to do that. The next round of studies will probably be different drugs and for a longer period of time, so watch for those. But think about that when you're designing your own trials. It's also important to use trials advanced. This is the one slide I forced the team here to add to my talk because I heard an earlier thing. You all, I think, mentioned some of these concepts. You have got to use any studies that you do to feed forward your knowledge of disease. And I think your NIH branch is different than my NIH branch, so I'll talk freely here. When I got my Stop RA study funded, the NIH did not want to hear that we were going to learn a lot about RA in the middle of our study, because they said, no, you have to do an intervention you think is going to work. You can't learn extra stuff in the study. And I'm paraphrasing. But you have to build into your studies more knowledge. So you have to say, this study is a pretty good try. We're probably not going to win. The next one's going to be even better. And the rheumatoid arthritis world has developed a group to say, when you do your study, please do these things so your next study will be better and the rest of the world will learn from your study. And that's been a hard thing to do. This is a European group, and it's not national, it's not international yet, but it will be soon. A couple of things, and then I'm going to be done. You have to agree on nomenclature. Somebody mentioned this from the panel. It's critically important, and I use nomenclature broadly to say classification criteria all the way down to just how you talk with somebody in an elevator about your disease process. It's important to harmonize science, improve communication and education. It helps you understand outcomes. You want to know if you go from the name, something named this to something named that, and have that be clear. It also helps in actually not helps, it's critical in regulatory approvals. It also helps if nomenclature is rooted in stage-specific biology, so it actually makes some sense. I'm going to just show you this a slide, which I forgot to take off this. Apologies. Watch this all go. So we have a bunch of names across this thing. In the bottom is our key terms. Nobody in rheumatoid arthritis yet agrees on these things, and I'm on the International Classification / Nomenclature Committee right now. We're trying to harmonize this. It's a huge area, and you have to start thinking about that now. What are you going to name a pre-MS, and has everybody going to agree with that? And then part of the problem here is because we don't have a nomenclature or agreed upon terms for these things, each of the RA prevention studies has actually had different inclusion criteria. That's partly because we've gotten smarter each time and we tweak it to make it better, but it also makes it very hard to compare. So if we had some classification criteria, it would even be better. So try not to make that mistake. Think of it ahead of time. I'm going to give an example of Teplizumab and type 1 diabetes. Have you all heard about this? So type 1 diabetes now has an FDA-approved drug, Teplizumab, which is an anti-T-cell therapy for treating a certain nomenclature established stage of diabetes called stage 2 diabetes, which is defined as beta cell autoimmunity, which is 2 autoantibodies in the blood, plus an abnormal glucose tolerance. You might even say that's not really prevention, but think of that model. It's a stage of diabetes that's better than full-blown diabetes, so think of it that. But they came up with this name. That name was important and critical for the approval of that drug. So now you can treat that condition with this immune modulatory drug. So the name really helped. Finally, you have to get a network of at-risk individuals. I think this was talked about on several levels already this morning, and I think probably yesterday as well. This is critical important. You can't move prevention without participation. So my Stop RA study, which is just completed, I'm not going into that in details, but we tested over 35,000 people for a blood marker for rheumatoid arthritis. 1% of the people were positive, and half of those people agreed to participate in our study, getting us to about 150 people enrolled in the study. When I told the NIH at the start that we were going to need to spend a third of our study budget on just finding people, they also said similar to things like you can't learn natural history studies from this. They said, oh my God, we can't do that. But you're going to have to do that. And these are scary numbers, but this is what needs to be done when you're trying to move in these earlier phases of disease to find people at risk. Importantly, Teplizumab was not approved out of the blue. It was on decades of work building huge networks for kiddos at risk for type 1 diabetes through something called TrialNet. I think that's an example of how this can be done. I'm going to give you the reference on the next slide. And you have to be, I wanted to say families are a great place to start because they are aware of disease. They may be at higher risk. But in RA, we've learned less than 10% of all RA is in a family with RA. So if you only targeted families with disease, you would miss lots of people getting the disease. I don't know if that's the same for MS. You think about that one, but that's a place to start. But participation may need to be beyond just people who already know about disease because of family. This is the type 1 diabetes TrialNet. Please, if you haven't read this, understand how they did this because this is how you build networks to do studies in the future. And then just as a brief summary, these are the things you need to have. I'm going to give the top 3 things I talked about and the 6 things we went into more detail, and I'm happy to answer questions on this in the panel later on today. And I'm going to give this picture. Hopefully this doesn't offend anybody, but this is a picture we've been using for several years now in our own study. This is a landing craft on D-Day, so these people were going to go into hell, and some of them weren't not going to make it back. This is how we feel it's been with trying to push RA prevention and getting a trial launched. And there's 2 phases to this. As I picked these pictures importantly, one phase is you've done a lot of work and you're in the boat and you're about to launch. Then you got to get out of that boat and go up on the shore, and it's even worse at that stage. This is how it feels. But let me tell you, once you got to do this, people have got to take the lead and push ahead, knowing this is going to be very painful, and it's going to be hard to find money. It's going to be hard to get people on board with this, but it's very important. And then I'll switch metaphors, if that's right, to this is a polio picture where these kiddos have gotten the polio vaccine, and they look pretty happy because you kind of... I'm not promoting EBV vaccines or anything like that, but who knows? But think about this. This is our goal, where we're actually going to be able to move ahead and get populations that are very happy. I will say rheumatoid arthritis is moving to the point where people are maybe scratching their head a little bit because we are still moving forward to find the right effective prevention. But at least with prediction, we can do some good things. The fact that we can now modulate disease, create a better version of disease in the future, even with intervention, is, I think, really spurring the field. And with that, I think I've gone over, but that's it, my last slide. Thank you.